All right. All right, so we're going to talk about something that it's going to be a bit more kind of tangible example of derivative function and derivative. So okay, so instantaneous velocity. Um, velocity is the derivative of the position function with respect to time. So the way we define velocity, first of all, velocity is the change in position divided by the change in time. Right. So for instance, an example that we can all relate to is if you're driving on the road, you are traveling a certain miles per hour, right? So miles is position and change in time is per hour. So miles per hour, that represents your speed, or in this case, velocity. But it's also the rate, because it's the rate of change of position. If we think of position as the original function, then velocity is the derivative, or s prime of v, is the rate of change of position. So s prime is just the derivative of position, and then we like to use v of t to represent. So they mean the same thing. If you see s prime means velocity, you can also use v to represent that first derivative. Okay, and then acceleration. The definition of acceleration is the change in velocity over the change in time. And because it's the rate of change of velocity, that means you're going to take another derivative down from position. So we think of acceleration as the first derivative of velocity if we're starting with v of t. But if we're starting with position, it's the second derivative. So we call this section PVA, position, velocity, acceleration, to show that relationship of function, first derivative, second derivative. Yeah.
Also, like when it's acceleration, it would be velocity prime in it.
Exactly right. Velocity prime. You can also think of it as position double prime. So if you think about acceleration, the units of measure, because let's say change of velocity is, let's say velocity is meters per second, and then change in time is per second as well. So a lot of times we see meters per second squared as the unit, or whatever, kilometers per hour squared. We always see that notation because of the fact that it's a rate of change already divided by another time component. Okay. The average rate of change is simply the change in position over change in time, but the instantaneous rate of change is the exact rate at that moment in time. Okay. Speed is equal to the absolute value of velocity. So velocity has direction, but speed is always just the positive version. Okay. So yeah, I'll go over some more example of that when we get to the next page. Okay. Next one I want to go over here is displacement. Displacement is how far you are from where you started, and distance is the total amount that you have traveled. Okay. So here's an example here. If I travel 10 feet to the right and then turn around and travel 3 feet back, then my distance is 13 feet, right? Because I've traveled 10 and traveled 3. So basically, you count your steps, right? So if I walk 10 steps and then I walk another 3 steps, in total, I walked 13 steps. But my displacement is only 7 because if I compare where I started with where I ended up, I'm only 7 feet away from where I started. Yeah.
So we're involving like physics in this.
A little bit, right? So, but it's not as heavy as, it's just going to be just a little bit. There's a little bit of overlap, but we're not going to see a whole lot of beyond that. Yeah. Okay. And then I have some notes here that we're going to kind of talk about here, or next page. Speed is considered increasing when your velocity and acceleration have the same signs. So if your velocity is positive and your acceleration is positive, that means that object is speeding up. Okay. If your velocity is negative and acceleration is negative, that also means the object is speeding up. But if your velocity and acceleration, if one is positive and the other is negative, opposite signs, then the speed of that object is decreasing. So I'm throwing a lot of notes at you, but we're going to kind of see it all played out in the next page with our example. And we'll revisit all these new rules here on the next page. Particle motion. This is linear motion describing the object along a line. So let's say an object only moves horizontally. Okay, so there's 3 things that an object can do. This object can either stay put, it can either move to the left, or it can move to the right. All right, so this object is restricted in terms of the direction of motion that I can do. So we call this a particle motion. It's just a linear motion for this object. Okay, so what we do is we represent the location of this object as x of t because he's moving along the x-axis. So that's why we call it x of t. Velocity is how fast this particle is going. If he's going to the right, that's positive velocity. If he's moving left, it's negative velocity. And acceleration is the rate of change of velocity. Okay. So the positive velocity indicates that the particle is moving in the positive direction, which is to the right. Because as he moves to the right, he's gaining positive values, but he's also, we associate right with positive. Okay, negative velocity means the particle is moving in the negative direction, which is the left. And then v of t equals 0. What do you think this means?
Stay put.
Yeah, that's right. Particle is at rest. So particle is not moving. Okay, next page. All right, let me read this problem here. A ball is thrown vertically upward from the edge of a building, and it eventually hits the ground next to the building. If the height of the ball at any time is given at time t, so we're only counting time greater than or equal to 0, because we're going to only start the timer after the ball is being thrown up in the air. The h of t represents the height of the ball at any moment in time. Okay, so we're given that equation here. So we're going to sketch a diagram of kind of just the important values. Let's say we have the the edge of the building here. And the ball is being launched off of the top of the building and is going to be thrown directly upwards, but eventually it's going to stop for a moment and then make its way down and hit the ground. Okay. Now we're going to use all of the derivatives or position, velocity, and acceleration. So the position here is represented as h of t. So this equation will tell us at any moment in time, we can find out the height, but we can also figure out, well, let's say I want to figure out at what time is this object going to hit a height of 100 feet, then we kind of work backwards as well. So anything that's location related, we're going to use this position function. We're also going to create a velocity function, which will tell us how fast this object is moving at any moment in time. And in this case, because the object is being thrown upwards, positive velocity would mean that the object is moving up. Negative velocity would mean that the object is moving down. Now let's go ahead and find the derivative, because velocity is the rate of change of position, and we can find the velocity at any moment in time. So what's the derivative of the first term here? Power rule. -32t. And these are easy power rule problems because we don't have to worry about any cleanup, right? No radical, no variable in the denominator, no parentheses. Okay. What does 64t become?
64t.
64, right? Imagine this was y equals mx plus b. Mx, this is going to be the number in front, right? You can also do power rule. 64t would become 64t to the first power becomes 64t to the 0 power, right? So that t to the 0 becomes 1. Yes.
This is probably like a dumb question, but for the 32t, can you do like are we allowed to do like a capital T so we don't get confused with the plus sign? Because I always I don't know.
Got it. You can, but typically, sometimes in future AP problems, a capital T can represent something else.
Okay.
But
So just
I wouldn't take any points off if you use capital T, but I would prefer lowercase t.
Okay.
Okay, so, and then what happens to the 80?
This becomes 80.
Well,
Or
what's
zero.
0? Good. So constant, the slope of a constant is going to be 0, so that goes away. Okay, good. Everybody good with 64t to 64? All right, so now let's find the acceleration. Acceleration function is simply the derivative of velocity. So what's -32t derivative? -32. And 64 becomes 0, right? Okay. So acceleration due to gravity, you've heard of that, -32 feet per second squared. Okay, so acceleration of this object is always -32, but we have these equations to work with. Okay, so now part 2 says, how tall is the building? Okay, how tall is the building? Well, we know that this ball is starting at the top of the building. So if I do h of 0, I can figure out the height of the ball at time t equals 0, which is where the ball is going to start. Which is what? 80. So h of 0 is 80. That means at time t equals 0, this ball is starting 80 feet off the ground. Yes.
Can you just can you just see that the 80 is a constant and just say? Constant?
Yeah. So I just want to kind of show that this is kind of a good setup for future later on. Let's say I want to figure out how tall the building is 2 seconds after, then we would use this equation to plug in.
Oh.
So it's a good, but yeah, you could definitely see this and recognize, okay, this is 80. That must be the height of the building.
So t stands for time, that's seconds that you put in.
That's right, seconds. Yeah. So because we know at t equals 0 seconds, the ball is still sitting at the top of the building.
So whenever it has a positive constant, that means that's where we're starting at.
I don't want to say that rule is for a sure thing, but we can always plug 0 in and figure out the location of whatever object if this is the scenario. Okay, so number 3 here, it says, when does the ball reach the maximum height? And we're gonna have to rely on this a little bit. Let's think about the velocity of the ball. So when the ball is being thrown upwards, what's the velocity just in general?
Positive.
Positive, okay. And then what's gonna happen as it's,
It's gonna like decrease the value equals to 0.
okay. And then what's gonna happen eventually though?
It's gonna stop for an instant.
Instant. And then when it stops for an instant, that is when velocity is gonna be what?
0.
That is also gonna be where the height is maximum. Yep, so that's the connection there. That's the connection. Because the ball is thrown straight upward, the moment that it stops is going to be when the ball is reaching the maximum height. So the connection there is, if I can set my velocity equal to 0, I can find the time where the ball is at rest for a moment in time, and we can use that to figure out when the ball reaches maximum height. Okay, so we set velocity equal to 0, so plug 0 in, not for t, right? Because we don't want to, because at 0, the velocity is still being thrown upward, right? We want to plug 0 into the velocity. We want to know at what time, right? Trying to figure out at what time is velocity equal to 0. Good. So here is 0 is equal to negative 32t plus 64. So t is equal to what? 2. 2 what? Seconds. So let's think about this here. So at 0 seconds, the ball is here on top of the building. 2 seconds later, the ball is going to reach its maximum height. After that, the velocity is going to become negative because it's going down. And at a certain time, it's going to hit the ground at how many seconds later.
You'll mark off a real land for it.
No, I won't. Yeah. So now that we know how long it takes for the ball to reach the maximum height, how can we find the actual maximum height?
We can T for H. I mean, T into H.
You're good, right. So we plug 2 in for t of the position function because we're asking for the location, right? This is a location problem. But we needed this information first before we can get to it. Good. So we do h of 2. We're going to find out at what height is the ball 2 seconds after it's being thrown up in the air. Okay. Okay, so I know you don't have a calculator right now, so I'll just do the math for us. This ends up being 144 feet.
What would you calculate for this section?
I'm just going to do the math for us on the quiz. The numbers will be more manageable. You won't need a calculator. So good so far. So we know that 2 seconds in, this ball is going to be sitting at 144 feet. After that, it's going to start dropping. Okay. So number 5 says, how long does it take for the ball to hit the ground? So we're looking for what variable here? How long? That means what? T, right? We're looking for T. We don't know what T is. Now, hitting the ground. So when it hits the ground, that means the height is what? 0. So that's our connection there. The ground has a height of 0. So how can we use this to help us figure out the T value?
Plug in 0 for the H.
Good.
T.
Plug in 0 for H of T, and then we can solve this. Okay, so 0 is equal to negative 16 T squared. Now this is factorable. I can take out a negative 16 out of each term here. It just makes it easier for us to factor. We can just focus on t squared minus 4t minus 5. Two numbers that multiplies to be negative 5, adds it to be negative 4. Okay, there's no variable t associated with negative 16, so that drops out. If we solve for t, we get t equals 5 and t equals -1. Now, which one is not going to fit into our problem?
-1.
-1, right? We're only talking about time after 0. So this is where we come to t equals 5 seconds. So 0 seconds, the ball is at the top of the building. 2 seconds in, it's 144 feet at the maximum height. And then 5 seconds after the ball is thrown, it's going to hit the ground.
Was that a extraneous solution?
Yeah, basically extraneous solution, right? Because at the beginning, we're told that t is greater than or equal to 0, right? Okay. So number 6, what is the initial velocity? So initial means, what does that mean? Initial.
Like as soon as it starts, like
Mhm.
words.
Yeah, so, but what value does that tell us? Initial means what is equal to 0? Time is 0. Okay, so time is equal to 0, initial velocity. So that means I can just find velocity at 0, right? Velocity at 0 seconds. The moment that the ball is being thrown, how fast is that ball moving up? So v of 0. Good. Now here's something that I'll be looking for on the quiz. What is the unit of measure here? Feet per second. Okay, so I'm going to ask for units of measure on the quiz. Right.
Okay. But yeah, sorry. In physics, like when we do these stuff, we used to take meters per second because he wants to do like feet per second.
It depends. Yeah, it depends on whatever the unit is given. So in this case, is feet is time and the time. Sorry, feet is the measurement, and then seconds is the time. Yeah, but yeah, so always pay attention to what is given to you. Don't always assume it's feet per second or meter per second. Look at how the problem is set up and then use that. Okay. Okay. So what's the velocity at 1 second? What's the velocity at 2 seconds? We can simply do what with these?
Plug in the 1 and 2.
1 and 2 into the velocity function. Okay. So v of 1. We'll skip a step here. So -32 times 1 plus 64. V of 2. Okay, we already know this, right? That at 2 seconds, the object is motionless. So it makes sense that at 2 seconds, we're getting 0 feet per second. Okay, what's the height at 3 seconds? So plug 3 into the what?
3 to the time or age.
And yeah, position function. Again, this is a big number here, so I'll do the math for us. Okay, number 9, what is the speed when it hits the ground? What's related to speed? Velocity. So let's focus on velocity first, and then we can worry about speed later. So let's worry about what is velocity. Now, when does it hit the ground? Did we find out from earlier?
Yeah, 5 seconds.
5 seconds in. Okay, so we know E equals 5 seconds. This one hits the ground. Let's find the velocity of this ball at 5 seconds, the moment that it makes impact. So let's find V of 5. We're going to focus on velocity first, and then we can worry about the speed later. So V of 5 equals.
That's 32 times 5.
I'll do the math for us here. This ends up giving us -96 feet per second. That is the velocity because it's moving downward, and velocity is a direction. So that's why we're getting that -96 feet per second. However, speed is always the what of velocity, absolute value. So if you see a negative, we got to make it positive. Yeah. So the speed is just the positive version of velocity. And if velocity is already positive, then the speed will just be the same number as that. Any questions so far?
So it's always the absolute value.
Always the absolute value. Always, yeah. So if you see a negative velocity, you can just turn it positive if it's asking for the speed of that object.
It's like why would the velocity be negative when it hits the ground? Because isn't it going back up in a positive direction when it's
Well, the moment that it hits the ground, it's still moving downward. It still has a downward force. Right. At the moment that makes impact. Now, what comes afterwards, that's past our problem, right? We're not worried about what comes after that. Okay, what's the acceleration at 1 second?
A 1 equals 32.
Okay, and what's the unit of measure there?
Feet per second.
Good, feet per second, which
Yeah.
will reduce to be just feet per
Feet per
second
second
square. So that's where we're getting that. What about A of 2? Same thing, right? There's no variable here, so whatever number I plug in, I'm going to get the same value in return
What's constant acceleration?
as a constant acceleration, right? Do the graph.
Square.
The reason why is because let me go back to this previous picture. So acceleration is change in velocity over change in time. So it's basically the units is going to be velocity over time, and velocity is meters per second. So if I divide meters per second divided by another second, if I clean that up, it becomes meters per second squared. Okay. So all right, so this is where we run into some trouble in terms of
Those intervals?
mistakes.
It was like X intervals.
Yeah. So circle 11 through 14, because these are the ones that we're gonna have trouble with. Not because it's hard, just because we have to kind of get used to the wording here. So it says find the average velocity between 0 and 2 seconds. Now there's a specific way that we describe average velocity. Average velocity is not the two velocities and then averaging them out. We define average velocity as the change in position divided by the change in time. So basically this, h of 2 minus h of 0 divided by 2 minus 0. Now, why do students have so much trouble with this? The reason why is because we see the velocity word here, but do we ever touch the velocity function? No. We are just using the position function to find the average velocity. Now, if it's asking for the instantaneous velocity, if we're trying to find what is the velocity at 2 seconds or at 0 seconds, then we'll use the velocity function. But here, we don't use the velocity function. And sometimes students want to use sometimes students realize that they don't have they understand it's not the velocity function, but they end up using the acceleration function. So we don't want to do that. We want to choose the position function, because if we want to realize that average velocity is a change in position over change in time. Okay. So h of 2 minus h of 0. So we have that information from previous things that we gathered. H of 2 is 144 feet minus 80 feet divided by 20 equals 32. Now, even though we never touched the velocity function, our units of measure is still going to be in terms of velocity, right? You got change in position over change in time. This is meters divided by seconds, sorry, feet divided by seconds. You're still getting. Does that make sense?
What's the variable for average velocity?
There's no variable for average velocity. Yeah, we're just going to say average velocity.
And for speed, there's no viewer.
Speed, we're just going to write it out as speed. Okay. Yes.
Where'd you get those 20 from?
Oh, sorry. 2 minus 0. Thanks for that catch. 144 minus 80 divided by 2 is 64. 64 divided by 2 is 32. Are we okay with this so far? I just want to give an example of this, of why we don't ever have to touch the velocity. Let's say you were on a trip and you knew that the trip took 300 miles, but then you were traveling over a course of 5 hours, right? 300 divided by 5 is 60 miles per hour. Your average velocity for that trip is 60 miles per hour, even though you had no idea, at any moment in time what the velocity is, right? All you knew was how much distance you covered, how much time it took to make that trip. You divided it out and you got your average speed without knowing anything, right? So that's why we can do average velocity without ever touching the velocity function, because it's just the change in position over change in time. All right. Now, how do you think we can define average acceleration?
Change in speed, change the velocity.
The change in velocity over the change in time. So, do we ever touch acceleration? We don't, right? We use the slope of the function above it. So the slope of position is velocity. The slope of velocity will tell us information about the acceleration. So here we do v of 2 minus v of 1 divided by 2 minus. Yeah.
Like test, are you gonna give us these like average acceleration formula and stuff?
No, you
Got
gotta
it, right.
know these, yeah. You gotta know these, yeah. Okay, so v of 2 is 0. Now we are talking about acceleration here. So what's our unit of measure? Feet per second squared. But yeah, put a start, especially next to these two. These are so, they cause so much trouble because it's really hard to see that word velocity and not use the velocity function, right? It's such a, it's like, well, if this mentions velocity, why do I not touch velocity? It's because of the fact that it's talking about the average velocity, and average velocity doesn't need velocity function to define it. So, yeah, it's a hard thing to overcome, but I just want to point that out to you. So hopefully you can avoid the mistake. Because a lot of students, when they see this, they realize it's slope. So they do v of 2 minus v of 1 over 2 minus 0. Or for acceleration, they'll do a of 2 minus a of 1. It's just so natural to want to include whatever function is mentioned, right? So just be aware of how troublesome these are. Okay, so now number 13, it says, is the speed increasing or decreasing at t equals 1 second? So let's go back to the definition that we talked about here. Speed is increasing or decreasing depending if the velocity and acceleration have the same signs or not, right? So if velocity and acceleration if they're both positive or if they're both negative, speed is increasing. If one is positive and the other is negative, then the speed is decreasing.
We plug in V1 and A1.
Yep, that's right. Good. So we'll find A1 and V1. I think we already have those values, right? So
At least one of them.
okay, yeah. So maybe we don't have V1. So let's find V1 here. Okay, so V of 1 is negative 32 plus 64, which is 32. A of 1 is negative 32.
So it's decreasing.
Good. So one is positive, the other is negative. It doesn't matter which is which. But the fact that they are opposite signs indicates that speed is what? Decreasing. Yeah. Yes.
Quiz, like, do we have to write all that out, or can we just like know whether it's positive or something?
I'm going to ask you to justify. So you just have to say something about the fact that whatever conclusion you come across, I want to see that you understand. You can say that V of 1 and A of 1 are opposite signs, but you have to indicate to me why you know that speed is decreased. So, yeah. Okay, and then yeah. So let me specify that. So we know speed is decreasing because velocity and acceleration have opposite signs. So that's the justification that we know that speed is decreasing. Number 14 is also another troublesome one. All right. Now it's asking, is the velocity increasing or decreasing? Is this talking about velocity?
Well, it says velocity.
It does say velocity, but you see this word increasing, decreasing? This is talking about, that's right, it's talking about the rate of change of velocity because of the fact that we see that word increasing, decreasing attached to it. And this is something that AP exam likes to do. They like to use that increase, decrease to see if students can see that it's talking about something else than what's being mentioned. So what's the rate of change of velocity? We define that as acceleration. So this is basically saying, this is the wording. Another way to say this is acceleration positive or negative?
Also, like
At
derivative
T.
notes, these derivatives are very changing.
It is, yeah. But it's asking, is acceleration positive or negative at t equals t? Now, you're not going to get the wording this way. You're going to get the wording this way. So typically what students want to do is they want to see, is the velocity positive or negative? But that's not the same wording, right? Is velocity increasing or decreasing? This is really saying, is acceleration positive or negative? So what's the answer there? Acceleration at 3 is what? Negative 32. Which means that the velocity is what? Decreasing. Yeah, velocity is decreasing at t equals 3 because acceleration is less than 0.
Wait.
Yeah, so let me write that out again here. So the troublesome thing about this problem is that they mention velocity, but we're making our conclusion based off of acceleration. Let me see if I can squeeze in one of these problems here. This is on page 29 in your packet. Number 4. Number 4 says, if a particle moves along a line, so imagine this particle is just moving along a line. This particle P, it's either moving left or right, but it's just going to be moving along that horizontal. Okay, so they give us that equation S sub t. How many times is a particle in the reverse direction? So in order for us to determine whether a particle reverses direction, if you think about a particle moving left and right, what happens for a moment before it reverses direction? It's got to do what before it's got to stop? So that's the key thing here. If we can figure out where the object has a moment of rest we know that's a potential place where this object could change direction. It doesn't guarantee it, but we know this has to happen if it's going to change direction, right? It's got to stop for a moment before it can move. So that's the key there. We're going to figure out where is velocity equal to 0. And then from there, we can decide, okay, does he actually change direction on either side of that, velocity 0? So let's find our velocity function. Okay. Go through power rule. This is nicely set up for us. What's the derivative there?
5.
5t to the 4th minus
Minus 20 to the third.
20t to the 3rd. We want to figure out when is velocity equal to 0. So I set velocity equal to 0. I can factor, what's the GCF here?
5.
Yeah, 5t to the 3rd. Okay, and I'm left with what?
D minus 4.
D minus 4, good. All right, I'm going to set both equal to 0 because I have two places where I can solve for t. So 5t cubed equals 0. What do I get? 0. Okay, I get t minus 4 equal to 0. I get 4. Yeah. So there's two places where this object changes direction at 0 and 4. Now, they don't tell us that we're restricted with positive numbers. So this is for all real numbers. So we're going to imagine that this object is going to be moving when t is negative as well. So we're going to create a number line. We'll put 0, 4 on the number line. And now we're going to test, is this object, let's figure out what direction it's moving, because we know that there's only 3 directions of motion here. It's either, it's going to move along the same direction for this entire interval, and then the same direction for this entire interval, and same direction for this entire interval. So we're going to test. So what's an easy number for me to test? I can test -1. I can plug -1 into my velocity function. Factor form is the easiest one to do. So if I plug -1 here, that'd be negative or positive? Negative. Okay, and then what about -1 minus 4? That's also negative. Negative and negative gives me positive. So that means in this interval, this object's moving to the right. Now, let's test a number that sits between 0 and 4. 1 is an easy number. Let's plug 1 into the velocity function. So 5 times 1 cubed is positive. 1 minus 4 is negative. Positive times negative is negative. So it does change direction here because it's moving to the right. It stops and moves to the left. Okay, let's figure out what's happening at 5. Because we can test any number that we want. We just want to pick what we think is the easiest number. Because we know it's going to be all the same, whatever number we choose to the right of 4. So 5 in for t, positive or negative? Positive. 5 minus 4 is positive as well. So this indicates that there's 2 places where this object changes direction because velocity changes signs.
So you plug in a number for what's before it, what's in between.
Exactly. Yeah. So particle reverses direction. At t equals 0 and t equals 4 because v of t changes signs. Okay, I'm going to modify your homework a bit. Your homework is going to come from page 29 to 32. Once I figure out what problems I want you to do, I'll send it out in a text remind this afternoon as well as Sunday, and also send the link where the solutions are so you can check. Okay, so I'll just have you do a couple of problems where you can see. It's okay. Come get your phones.
Can you put the answer back
Yeah.
So you have so much fun. So are you ever going to use vectors and stuff like this? Because I know they're kind of
Vectors. We're going to use vectors. We're going to be
okay.
Oh, we get supply.
And usually. Oh, you know how I